In this example, we have a calorimeter cup with a stirrer and are made of aluminum. Water is also present in the calorimeter cup. The cup with stirrer and water are initially at thermal equilibrium at temperature of T1. Small ice cubes are then added to the system with an initial temperature of Ti. The initial temperature of ice is taken to be 0 degrees Celsius. We are then asked to determine the expression for the latent heat of fusion when the system reaches equilibrium. At equilibrium the system is at temperature of Tf. Here we write the given parameters. T1 for the initial temperature of the calorimeter with stirrer and water. Note that the calorimeter and stirrer are made of the same material, which is a pure aluminum. The mass of the calorimeter, the mass of water, the mass of ice, and the initial temperature of ice. Then the final temperature of the system Tf when it reaches thermal equilibrium. The energies that are related to the system are shown here. We have the heat or energy related to the calorimeter with stirrer and are both made of aluminum. The heat from the water inside the calorimeter. The heat from the ice added. The heat of fusion for the conversion of ice to liquid water. Then we have heat for the water from ice being raised from 0 degrees to the final temperature. We recall the conservation of energy, which can be expressed by the formulation shown in equation 1. Plugging in the different energies or heat, we have equation 2. Expanding the equation for the net heat, we have equation 2. Substituting the equations of the different heat, we have equation 3. Looking at the graph for the temperature versus heat of the ice, we see that it starts at 0 degrees. At this point heat here is for the melting of the ice. Since the ice is gaining heat at this point, then it is a positive quantity. We note that at this point the initial temperature of the ice added is 0, but also the temperature for the ice to melt. So, the Q of ice is 0 since there is no change in temperature as shown in equation 4. So we have the expression in equation 5, which is the effect of the previous calculation. Rewriting this further, we have equation 6, here we transpose the other terms. Dividing both sides with the mass of ice, we get an equation for the latent heat of fusion shown in equation 7. Steam with an initial temperature of Ts added onto the system and determines the latent heat of vaporization when the system reaches a thermal equilibrium of Tf. Note that the initial temperature of the calorimeter and water is T2. The energies that are related to the system are shown here. Heat related to the calorimeter. Heat related to water and the water from ice. So this is basically the sum total of water. Heat related to steam. Heat related to latent heat of vaporization during the condensation of steam to water. In this case the steam is losing heat, so this parameter is negative. Then we have heat related to water from the steam that was converted. We again recall the conservation of energy as shown in equation 1. Adding the different heat to this equation, we have equation 8. We then expand the equation by plugging in the equation earlier and we have equation 9. Here we examine the temperature versus heat for the steam that was introduced in the system. We see that the steam starts to condense at 100 degrees. The condensed steam turns to water and it is lowered at the final temperature. Heat from the steam is 0 since we see that the initial temperature is equal to temperature during the transformation, which is 100 degrees. So the contribution from this heat is 0 as shown in equation 10. So we have equation 11. Rewriting the equation to solve for the latent heat of vaporization, we have equation 12. Then dividing both sides by the mass of the steam, we arrive at the equation for the latent heat of vaporization as the steam is converted into water. This is shown in equation 13. That is it for now, and I hope you learned something new today. For questions and comments you may send them to diyslearningstuff@gmail.com. You may review the slide on YouTube at @diyslearningstuff. Note: please do not forget to use your school email. Also write your complete name and a class section. Thank you for listening and see you next module.